Thanks for clicking. Welcome to another Knowledge Math production. Today we're going to be talking about rational and irrational numbers. We're going to be classifying numbers based on the category that they belong in. So we're going to add to our rational numbers that we already have. We're going to add irrational numbers. So let's get started, see what they're all about. Make sure that you remember how to look at these, and we'll go from there. Make sure you can classify them all. Okay, so here's almost the same diagram that we had in the last video, except it now has a second side to it, right? So this is how real numbers are classified. Real numbers are any number. Okay, any number is considered to be a real number. So every number falls in the real number category. All right. And then on the left-hand side, we have rational numbers. Rational numbers are fractions, repeating decimals, negatives, mixed numbers, okay, terminating decimals, positive numbers, negative numbers. So 4, -2, that's a rational. Those are all rational numbers. Also, any number that could be written as a fraction. And then integers are our positive and negative whole numbers, and 0 as well. Whole numbers include 0, okay, and then the whole numbers, 1, 2, 3, 4, 5. And then underneath that, we have the natural numbers, or the counting numbers. They're the first numbers that you learned when you were a kid. Okay, you didn't start with 0 when you were a kid. You started with 1, right? So those are your counting numbers, or natural numbers, we call those. All right, an irrational number is a number that has a decimal that's non-terminating. We're going to look at that. Okay, it's a square root that doesn't give you a whole number, right? So square root of 25 would be a rational number because that answer is 5. But square root of 17 doesn't give me a whole number. It gives me some kind of crazy decimal. So that's an irrational number. All right, that's the difference between the two. So we have a slide for each. Okay, so rational numbers are all the numbers that can be written as a ratio. We did that in the last video. Of integers. They can be written as a fraction as long as a and b are integers. So again, it's 1/2, -2/3, -8/7, 2 5/6, 0, 5, -3. All of these are examples of rational numbers. The square root of 25, because it's 5. Right? So that is a rational number, square root of 25. It gives me 5. Okay? These are all 0.4. How about 1.2 repeating? That is also a rational number if it has a repeating bar over it. All right? Those are all rational numbers. Irrational numbers are non-repeating decimals, so decimals that go on. Whoops, I put a comma there. They're just kind of random, and then they don't stop. Okay. Non-terminating decimals. All right. And then there are numbers that cannot be written as a fraction. Okay, so like square root 7 can't be written as a fraction. I don't know what the square root of 7 is. I have no idea. Okay, it's not a square root that you know off the top of your head that gives you a whole number. Pi cannot be written as a fraction. That's a good non-terminating decimal, right? It just keeps going on forever. Okay, those are the kinds of numbers that we're talking about. All right, so they're the numbers that are definitely weird, stranger than others. So determine if each of the numbers are rational or irrational, and then we're going to give a reason for each. So -2, that is a rational number. It can be written as a fraction. Okay. It can be written as a fraction. It is rational. 0 is also rational. Now, -7, I don't know what the square root of 7 is, so this is irrational. And then 1/3 is a fraction. Fractions are ratios, so they are rational. Okay, so there's your answer for those 4. And then you should also have a reason for each. Okay, same idea. Your turn. 5, it's rational. It's a can be written as A divided by B, right? Okay, it can be written as 5 over 1. 5 over 7, that's rational. It's a ratio. It's a fraction. 0.575, that's rational as well. It's a terminating decimal. Okay, it's a decimal that has an end. 0.575, and it stops. Square root 5, that one's irrational. I don't know what the square root of 5 is. It's a non-repeating or non-terminating decimal. Okay? Non-terminating decimal. All right. So far, so good, hopefully. Okay, same idea. Determine if these are rational or irrational. 1.233 with the bar on top, that will be rational. Okay, it's a repeating decimal. 1.245, and then it goes on. That's irrational. It's non-repeating. 3/5 is rational. It's a ratio. And 3 pi is irrational because it has pi in it. Okay, and pi is the most famous irrational number that we have. And that's it. So we're determining whether or not values are rational or irrational, and then we're going to work our way on from there. And as always, thanks for clicking.